Hello children, now we are going to learn question number 6 of exercise 7.4 in this video. In previous videos, we have done question number 1 to 5. If you have not watched, not learned, please see those videos and learn it. Here let us see question number 6. The question is here: diagonal AC and BD of a quadrilateral ABCD meet at O or intersect each other at O. So, we start with this. This is a diagonal, this is a quadrilateral, it has two diagonal, two opposite vertices are joined, we get diagonal, that we all know. So, AC and BD we can see clearly in diagram. In question diagram may not be given to you, you have to draw the diagram. We will see the condition what is here: diagonals AC and BD of a quadrilateral ABCD intersect at O. We have drawn the diagram. Now, what we have to prove? There are two Roman number 1 and 2 in your question to prove. Here we start with one number. To prove, first one is AB plus BC plus CD plus AD, that means 4 sides of quadrilateral. The sum of the 4 sides of quadrilateral is greater than the sum of its diagonals AC and BD. So, surely if we look at the diagram, we will feel that sum of 4 sides will be surely greater than the sum of diagonal, but thing is that theoretically how to prove it, we are going to learn from here. So, the two property what I have reminded you, I have told you in previous videos, I hope you may be remembering, that was what? In any triangle the sum of any two sides is always greater than the third side, and one was about angle property, angle and side relationship, like greatest angle longest side, shortest angle smallest side, those things. So, here in this question we are going to use the sum of any two sides of a triangle is always greater than the third side. So, when we look at these diagonals are making some triangles there, we need to see that. If we see this using this diagonal AC, we will find triangle ABC. That means, in that triangle the sum of any two sides, let us say we have to prove sum of 4 sides. So, we will take these two sides, AB plus AC will be greater than the third side, that is AC. Nothing to do, just look at the figure and write down it, enough. So, in triangle ABC we see these two sides sum will be greater than the third side, that angle, that property is there, property of side. So, AB plus BC is greater than AC, we mark it as equation 1 and keep. Now, we will look at another triangle. Which triangle you see? BDC. So, in this triangle now what we find? These two are sides and this is diagonal. So, sum of these two sides CD plus BC is greater than BD. We just write that in triangle. Which triangle we look at? We use this property and write down, only that is the solution, nothing more we are going to do here. So, in this triangle we found BC plus CD is greater than BD. Do you see some more triangle in the figure? Yes. What is that? ACD, this triangle, we write that. Which triangle we look at, we write down that. We find geometry is very difficult sometime, but nothing like that. The whole solution is hiding in the figure, look at that and write down. Geometry is done that way. Surely we need to remember the properties and all those things. So, in triangle ACD we are using sum of any two sides is greater than third side. So, these two sides AD plus CD or CD plus AD, same thing, is greater than the third side AC, equation 3. One more triangle do you see? Yes, that is ABD, this triangle. Here what we find? Two sides AB, AD will be greater than the diagonal BD, that is the third side of that triangle. So, we write in ABD, in triangle ABD, AB plus AD is greater than BD. 4 equation we got. Now, we do not find here using these two sides, only this 4 triangle what we have used. And then what we need to do? We need to prove here sum of 4 sides is greater than the sum of diagonals. So, surely sum mean adding we will get. So, we will add equation 1, 2, 3, 4. Adding is also not difficult. We will just look at the LHS of all the equation and write with plus sign, only that is the adding. So, first equation LHS AB plus BC, second equation BC plus CD, third equation CD plus AD and fourth equation AB plus AD. sign is in middle what? Greater than. And then RHS of first equation, we will look at what is that? AC, we will write AC. Another one is BD, we write BD. Third equation RHS is AC and fourth equation RHS is BD. Step is very long, that is why we put here this sign and then brought this RHS part from the half. We will not start the incomplete step from the beginning. Remember, any incomplete step will start from the halfway. That is the rule in mathematics. I will tell you, this is a small thing we need to be careful about. Anyway, now we will see AB plus AB, 2AB, BC plus BC, 2BC, CD plus CD, 2CD, AD plus AD, 2AD. Very simple, no calculation, nothing is here. In RHS we see AC plus AC, 2AC, BD plus BD, 2BD. So every term has 2, we take 2 common, inside the bracket remain AB, BC, CD plus AD. RHS also 2 we take common, AC plus BD. So you know already equation, if we take this 2 in RHS, it will be 2 by 2. So better cut from both sides straight away. Remaining what? AB plus BC plus CD plus AD is greater than AC plus BD. This is what we need to prove here. We needed to prove, and we proved in any quadrilateral, sum of the four sides is always greater than the sum of its diagonals. I hope you have understood. Let us go in Roman number 2 of this question. So, let us see now in the same question, question number 6, second one, what is another to prove? The condition is same, this is a diagonal, this is a quadrilateral, it has two diagonal, they intersect at O. We have to prove AB plus BC plus CD plus AD or DA, the sum of four sides is less than 2 times the sum of diagonal. I just said in the word 2 times the sum of diagonal. AC and BD are diagonals. So, 2 into AC plus BD. In last question, in one number of this, we have worked what? Sum of four sides of the quadrilateral is greater than the sum of its diagonal. But now here we are going to prove if we double the sum of diagonals, then four sides will be smaller. I hope you have understood the question. Sum of four sides of quadrilateral is smaller than 2 times the sum of the diagonals. So, let us start. Here also we will use the same property, sum of two sides of a triangle is always greater than the third side, but we will work in this 4 triangle. You may be remembering in last one what we did, we worked in this triangle, the one diagonal was dividing which triangle, we worked in those triangle ABC, BCD, ACD and ABD to prove 4 side is greater than sum of diagonal, but here 4 side is smaller than 2 times the sum of diagonal. So, we will work in this 4 small triangle. Let us start the work, very easily we can do. We see first triangle, it is not that we will start AOB, whichever triangle you wish to start, one after another go in all 4 triangle. So, we start AOB triangle. So, OA plus OB is greater than AB, we just write down OA plus AB is greater than AB, equation 1 property. Once we write and rest we continue, no need to write this property with every triangle. We know that it happens in all the triangle. Next we see BOC. So, OB plus OC is greater than BC. We just write down that. We look at the triangle COD. OC plus OD is greater than CD. We write down, that is equation 3. AOD triangle we look at. OA plus OD is greater than AD. We write down equation 4 and then we add all that 4 equation. Because what we need to prove, we find plus only. So, adding equation 1, 2, 3, 4. Adding equation mean LHS of first equation OA plus OB, second equation LHS OB plus OC, third equation LHS OC plus OD and fourth equation LHS OA plus OD. Sign is greater than, we use greater than, and RHS of first equation AB, second equation RHS BC, third equation RHS CD and fourth equation RHS AD. Then what we see? OA, OA, 2 OA, OB, OB, 2 OB, OC, OC, 2 OC, OD, OD, 2 OD. But when we write this, we need to be very careful. If we look at here, if we write 2OA, it looks like we wrote here 20A. So there should be little gap between 2 and OA. Small thing, but we should mind this all. We write here 20A or 2A, it will be little confusing. So be careful whenever you write this kind of term, little gap you leave. So 2OA, 2OB, 2OC, 2OD, otherwise it will look 20A, 20B, 20C, 20D. Try to avoid that kind of thing. Is greater than AB plus BC plus CD plus AD. Now what happens? 2 we will take common. In RHS nothing is there to take common, all are separate thing, AB, BC, AC and AD. So 2 we took common, OA, OB, OC, OD, and then we refer the diagram. We look at OA and OC, this part are the part of diagonal AC. So we bring it together, OA plus OC. Seeing the diagram only we will know. Only we look at here and we see OA and OC, why came together. The diagonal is telling that OA and OC, if we add, this is the full diagonal AC. The same way OB and OD, look at OB and OD, this together is BD. So we brought them together and we get 2 OA plus OC, AC, OB plus OD, BD. We are seeing the diagram also is greater than sum of 4 side AB, BC plus CD plus AD. So what we found here, 2 into AC plus BD is greater than AB plus BC plus CD plus AD. So this is greater than that, or that is smaller than this, meaning is same. So we just reverse it. Therefore AB plus BC plus CD plus AD is smaller than 2 into the sum of diagonal AC plus BD. These both are very easy. Thing is that if we simply look at the geometrical solution with ABCD, we won't understand. We need to refer the figure. I told you one sentence about that, whole solution is hiding in the figure. We need to keep our eyes very nicely, observing eyes, not looking, just simply seeing and then where is the solution. We will not know. We have to remind ourselves the property, find out what is hiding here and write down. Geometrical solution is done. I hope you are enjoying this geometrical solution. See you with the next solution of next question in new video.